Hidden Markov model. Hidden Markov model is a probabilistic model which is based on Markov process or Markov chain. This hidden Markov model is used to describe the probabilistic relationship between the sequence of observations and the sequence of hidden state. So in this experiment, we will be implementing hidden Markov model using Python. So the objective of the experiment is that to find the sequence of hidden states by the known sequence of observations of the given model. Here in the model we have two hidden states, which is sunny and rainy, and two observable states, which is happy and sad. So this is the given model. This picture over here represents the transition between the hidden states and the observable states. So for this given model, we will be finding the transition probability and emission probability in the following way. The transition probability is nothing but the probability of transition from one hidden state to the another hidden state. Here in this case, we have two hidden states, which is sunny and rainy. So we will be calculating the transition probability from sunny to sunny, sunny to rainy, rainy to sunny, and rainy to rainy. Moving to emission probability, it is nothing but the probabilities of observing certain observable states, which is happy and sad, given the hidden states, which is sunny and rainy. And the initial probability is given as zero point 0.5 and zero point 0.5. The given sequence of observable state is happy, 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 sad, sad, and happy. So for this particular model, we will be implementing the Python code. Moving to the Python implementation. So in our Python code, initially we will be declaring the transition matrix, emission matrix, initial probability, and the observed sequence of the model, followed by alpha initialization and forward algorithm. Then we will be calculating the probability of observed sequence, then the most likely sequence determination. So here in the Python implementation, we will be declaring the transition matrix, emission matrix, initial probability, and observed sequences. Here we will be declaring all the four variables in a matrix form, which is in array, and so we will be using NumPy. So the transition matrix and the emission matrix are represented in the following ways. And for the sequence of observed states, which is happy and sad, here we will be denoting happy as 1 and sad as 0, and thus the observed sequence will be like 1 1 1 0 0 and 1. After the declaration of all the four variables, we will be moving to the alpha initialization and forward algorithm. So the alpha initialization initializes the forward variable, which is the alpha, which represents a probability of being in each hidden state at each time step given the observed sequence up to that point. The forward algorithm is used to calculate the probability of observed sequence and to find the most likely sequence of hidden states. It iterates over each time step and computes the forward variable using the forward recursive formula for HMM. After the initialization of alpha, we will be moving to calculate the probability of the observed sequence. The probability of observed sequence is calculated by summing the probabilities of being in each hidden state at the last time step. The output of the probability of observed sequence for the above model will be around 0.0189. After calculating the probability, we will be moving to find the most likely sequence. In order to find the most likely sequence, we will be using a for loop over here. Based on the values of the forward variable alpha, the most likely sequence of the hidden state is determined by choosing the hidden state with the highest probability at each time step. And the output for the following code would be sunny, 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 rainy, rainy, and sunny. Here comes the execution of the Python code. So initially we are declaring all the four variables, which is the transition matrix, emission matrix, initial probabilities, and the observed sequence. Then followed by alpha initialization. Then we are calculating the probability of observed sequences, and the output is around 0.01890. Then moving to the most likely sequence, and the output is found to be sunny, 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 rainy, rainy, and sunny. This is the Python implementation for the hidden markup process for the given model. Finally, the application of HMM. Applications of hidden Markov model. So it can be used in speech recognition and bioinformatics. In speech recognition, it can be used in named entity recognition, and in bioinformatics, it can be used in the field of gene prediction and protein structure prediction. Thank you.